have. Okay, if we say dy over dx, that is called the first derivative. If you take one more time derivative of this one, for example, if you will take the derivative of this one, then mathematically we write it like this. And we read it d2y over dx square. Like this one we read dy over dx. This one we read d2y over dx square. Okay. This is called second derivative. Okay. Now, for example, if I have to take the two derivative of this one, how I will take? To take the second, you must need the first derivative. You are asked to find d2y over dx square. So how I will find? Take the derivative of this one. It will be dy over dx. What it will be equal to? Use the power rule. Bring the power down. 1 minus from the power. Plus for this 5 into 1 plus 0. So what is dy over dx? That will be 2x square, 3x square plus 5. This is our first derivative. But if I have to find the second derivative, it means I will differentiate this one now, one more time derivative. So this will become d2y over dx square. That will be equal to, now take the derivative of this one in the same method. Bring the power down, 1 minus from the power, plus now for this one will be 0. So we will have 6x. Okay, this is called taking the second derivative. Now let me give you an example and ask you to find the two derivative of this one. We are having y is equal to 5x power 4 plus 3x square minus 5x plus 2. Question is find d2y over dx square. Yes. How 2x? Because I'm taking the derivative of this one, yes. So 3 I will write as it is, and for x square, when I will take the derivative, I will bring the power down, it becomes 2 and 1 minus from the power. Okay, understood? Because same method I will use, the one we use for the first derivative. Okay, let's find this one please, and let me know when you complete.
Done, sir.
Done?
Yes, sir.
Okay, let's see. What you will do, take first derivative. What it will be, dy over dx. Okay, from this one 5, for x power 4 use the power rule, bring the power down, 1 minus from the power, plus now for this one bring the power down, 1 minus from the power, plus, sorry, it is minus, 5 into for x it is 1 and then plus 0. So what it will be 5 into 4 20 x cube plus 6x minus 5. This is our dy over dx. Then take another derivative, that will be d2y over dx square. That will be 20. Now bring the power down, 1 minus from the power, plus 6 into 1 minus 0. So that will be 60x square plus 6. Okay, that will be our second derivative. Okay, so now this is the way to find the second derivative. But where we use the second derivative? Second derivative help us to know, like for example, if I have these 2 points, this is one of the stationary point, this is another stationary point. We don't know which one is maximum, which one is minimum, because our stationary point, our turning point can be maximum, can be minimum. For example, if I say this one is maximum. If I say this stationary point, this is minimum. But how mathematically we will come to know that a given stationary point is a maximum or minimum? So the procedure will be like this one. That is called nature of stationary point. Okay, nature of stationary point. For the nature of stationary point, remember how you will determine. First step will be first find stationary point. Okay, stationary point, or we call it turning point. Second step is, after finding the stationary point, then find d2y over dx square, means second derivative. Okay, first find the stationary point, then find second derivative. Then third step will be put stationary point in d2y over dx square. Okay, if it is positive, I mean greater than 0, the value you get greater than 0, then it is minimum. Okay, keep in mind it will be, we will say it will be minimum. But if it is negative, then mean this d2y over dx after putting the point, then point is maximum. How? Let's see. I will do one example. If you want to take the screenshot of this one to remember these steps, so you can take that. I'm taking a curve 2x square plus 5x plus 7. Question is, find turning points. Turning or stationary, it is same thing. Okay, and discuss its nature. Nature mean you have to tell whether it is maximum or minimum. Okay, so first find dy over dx. Because first you have to find the turning point, then you will discuss the nature. So what will be dy over dx for this one? Using power rule, plus for this one, what will be derivative? Sorry, it will be 5 into 1 plus for this one is 0. So we will have 4x plus 5. This is dy over dx. Okay, now put it equal to 0, so you can get the stationary point. Dy over dx equal to 0. We will get 4x plus 5 equal to 0. So take it to the other side. 4x will become 0 minus 5, which is minus 5. So x will be minus 5 over 4. Now minus 5 divided by 4, it is minus 1.25. So x is minus 1.25. This value of x you can put here. You will get y. 2 into minus 1.25 plus 5 into minus 1.25 plus 7. So what we will get? 2 into minus 1.25 plus 5 into minus 1.25 plus 7. So that is 3.875. That I can round to 3.9. Okay. So it is 3.9. So therefore, your stationary point, what is the stationary point? It is minus 1.25, 3.9. Now we have to check whether it is maximum or minimum, because the second part is saying discuss its nature. To discuss the nature, take the second derivative. Now this is your first derivative. Let me write here. Your dy over dx is 4x plus 5. Take another derivative. That will become d2y over dx square. If you will take the derivative of 4x, it will be 4 into 1 plus the derivative of 5 will be 0. So that will become 4. d2y over dx square is 4. Now what you should do, put this point in this one. You know, this one is x, this one is y. So I will say d2y over dx square at this point minus 1.25, 3.9. You can see we don't have any x or y here. So it means it will not change. So it will still be 4, because if I will put the value of x here, we don't have any x, y here. So it will still be 4. What is this one? This one is greater than 0. Mean you got a positive answer. When you will get a positive answer, so what will happen? The stationary point is minimum. Because when we get a positive answer, the stationary point is minimum. If you will get a negative answer at this step, then the stationary point will be maximum. Can you try one example, please? Let me give you one example here. Yeah, I will repeat briefly. Once again, sorry. To discuss the nature of the stationary point, what you have to do, first find the stationary point. That already we learned. Till this one, I found the stationary point. Okay. This is not a huge calculation. Okay, it's normal calculation, don't worry. After finding the stationary point, what you have to do, take another derivative, because this was our dy over dx. This was our dy over dx. I took another derivative, so I got 4. Then I will put my stationary point in the second derivative. Already it is just 4, so whether you put or not, it will remain same, because it is free from variable. Its value will never change. 4 is a positive value. When you get the result positive, the stationary point will be minimum. If you get a negative answer, the stationary point will be maximum. Let me give you one example so you will have better idea when you will go through the real steps. Okay. Y is x square plus 3x plus 5. Question is find stationary points. And discuss nature. Okay, I'm waiting for your response. First find your stationary point, then take second derivative, put in that, so you will get. Yes, please let me know if you complete. Okay, let's see now. I will do the calculations carefully. You can see. This is y. First find dy over dx. It will be 2x plus 3. After simplification, I'm writing because now you are expert in taking the derivative. Then for stationary point, what you have to do? Put dy over dx equal to 0. When you will put this equal to 0, you will get 2x plus 3 equal to 0. The value of x will be minus 3 over 2, which is minus 1.5. This value of x put here, so you get the value of y. So y will become minus 1.5 square plus 3 into minus 1.5 plus 5. Let's calculate that one. Minus 1.5 square plus 3 into minus 1.5 plus 5. So that is 2.75. So y is 2.75. So therefore, what is our stationary point? It is minus 1.5, 2.75. But now we have to discuss the nature of the stationary point. For that, take another derivative. This is your dy over dx. Take another derivative. What it will be? d2y over dx square. What will be the derivative of 2x? It will be 2 into 1 plus the derivative of 3 is 0. So that will be 2. Okay. Now put this point inside this one. Mathematically, we write it like this. At minus 1.5, 2.75. So what the result will be? This point when you will put here, you will get it equal to 2. Because we don't have any x, y, so obviously the answer will be 2, which is clearly greater than 0. So therefore, what is the nature of stationary point? The stationary point is minimum. We call it minimum, or another word is used, local minimum. Okay, that is